Hey everybody, it's Mr. G. Welcome back to the channel. What we're going to be doing today is using a voltmeter and some very common procedures to troubleshoot some electrical issues inside your car. So please take a moment, subscribe to the channel. I'm going to head on inside. Be right back with you.
Hey folks, this is Mr. G and welcome to Just Corvette Crazy. On this channel we talk about Corvettes, we fix some Corvettes, and we love to drive our Corvettes. So if you like what you see, hit that subscribe button. It really helps the channel out a lot. Thanks. Alright folks, so we're at the bench now. And what I've got set up here is a simulated wiring harness for a car. So what we're going to do is we're going to use a C5 Corvette as the example for today. Now this procedure can be used for any Corvette, any car, anything at all. So what we've got, and I'll run through the little setup for you, is I've got a battery. So it is a 12 volt Automotive battery. I have a cable coming down from the battery to my chassis. So this piece of aluminum is going to represent the chassis. Then I have a hot line coming down to a couple of fuses. So this will represent my fuse panel. From the fuse panel out comes a couple of circuits. We have a switch here that goes off to this light bulb and a switch that goes off to this light bulb. And then both light bulbs are grounded through the chassis. So if I flip the switch, we'll see that we have a light bulb there, and if I flip this switch, got another light bulb there. So what we're going to be covering today is different scenarios for testing for bad connections inside the system. So we're going to look for bad grounding connectors, and we'll be looking for bad hot line connections. And I'll show you what it looks like. So the only thing that you need to do the tests on your car is a voltmeter. So I happen to have a multimeter here set up to measure DC volts, and you can see my screen right here. And just to show you what it all looks like, I'm going to go directly to the battery, so red to red, black to black, and I am getting a voltage approximately 12.7 volts, so a fully charged battery. Okay. So that's what the system looks like, and what we're going to do is we're going to simulate different issues inside a wiring harness, and I'm going to show you how that shows up on a voltmeter. So it'll help you narrow down where your issues are by the voltage you're getting at different points in a circuit. So let's get started. Okay, so what we need first is a good baseline. So what we have is a perfectly good working system. So I have turned on my switches and my two lights are on. The lights are the proper brightness, everything looks good. So what we're going to do is we're going to take some voltage measurements of the baseline system, so everything working. So what I'm going to do, I'm going to go right to the battery. So at the battery I'm getting 12.68 volts of the loaded system. Now what I'm going to do is I'm going to go from the positive on the battery to my chassis ground. And I'm getting 12.6 volts. You can always expect a slight difference between the two, very, very slight, because there's no such thing as a perfect connection and a perfect wire. So we are going to lose a small amount of voltage always. So here's what we're looking at. Go again directly to the battery and I get 12.68. I go from the positive side of the battery to my chassis and I'm getting 12.57. So that's a good system. The other thing we're going to check is we're going to go from the ground on the battery to the input of our fuse panel. Again, 12.6 volts. So, good system. Now what we're going to do is I am going to go to my chassis. And I'm going to measure to each circuit. So here's this light bulb. Again, we always lose a little bit. 12.8, that's good. Go to this light bulb. Again, so sorry, 12.28, 12.28. So we're good. So the battery, the system is performing as it should. So in a good working system, the voltage at the battery should just be within a few tenths of everything else. So directly across the light bulb should be within a few tenths of the battery. Directly across the light bulb should be within a couple of tenths of the battery. And if I go from my hot line into my fuse panel and go to the chassis ground, again within a few tenths of the battery voltage. This is a working system where all of the voltages are relatively the same. Alright, so the most common problem that we find in electrical systems in cars is actually bad connections at the terminal points where we connect to the battery. So the actual connector that goes onto the battery post has become corroded and giving a bad reading. So what I'm going to show you is how to, by using a voltmeter, how to detect that particular issue. So what you want to do is you want to turn the lights on your car, and you want to take your voltmeter and you want to go directly to the battery terminals. So the battery terminals, not the actual connectors, but the posts themselves, or the screws themselves. So what you want to do is you want to go directly across the battery and you're going to get your baseline reading, so 12.68 volts or 12.69 volts. What I'm going to do now is I'm going to introduce a bad connection on the negative side of my battery. By introducing a resistance to that system. Okay, so basically, if I can get this in here, like that. So basically, there is now a resistance that has built up between the post and the actual connector. So that'd be right there. So now, here's the system. So, again, if I go directly across the post of the battery, I get 12.68 volts. Now, I move my connector, and I move my connector to the actual battery connector itself. So not the post, but the connector. I have a voltage drop. So I've lost a couple of volts. So just going from the post of the battery to the connector on the battery. That shows me that under load, when current is being drawn, that we actually have a voltage loss from the post of the battery to the actual wire that goes to the chassis. So the connector itself has gone bad. If I wanted to do that same test, but on the positive side, so I want to do the same test, but on the positive side, it would look like this. So I'm now introducing the bad connection on the positive side. So I go across my battery and I get my 12 point whatever volts. Now if I go to the battery connector, so not the post, but the actual connector, I'm going to read 9.4 volts. Okay, that will tell you that the bad connection is on the positive side. It is very common. If you find a bad connection on the positive or the negative side of the battery posts, clean them both, so that you have, or you're starting off with always a good connection leaving your battery. So again, go directly to the post of the battery and then touch the actual connector that goes onto the battery and see if you see a difference in voltage. If you do, then the connection is bad. If I take away my circuit, so I turn off all my lights, I don't get that drop. It only happens when current is flowing in the system. So that means that there's load on the battery. If there's no loads on the battery, so that means no current is being drained from the battery, these bad connections do not show up. So put your headlights on. Measure from the post of the battery to the connector. If there's a difference, then you've got yourself a problem. Alright, so what we're going to start doing now is we're going to start introducing faults into the system, and we're going to be taking the same type of measurements each time, and the difference in the measurements will give us an idea of where the fault is. So, the first one we're going to do is very, very common. It is a bad connection at the main chassis ground coming from the battery. So from the battery to your chassis, that connection has gone bad. So it has corroded and become a bad connection. So what I'm going to do is I'm going to simulate that bad connection by introducing a resistor into that line. So basically, as your connection becomes bad, it builds up a resistance at the actual connection point. So what I'm going to do is I'm going to simulate it with this resistor. So I'm going to basically just put this resistor in line, and that is going to simulate a bad connection at my chassis. So now what you might notice is my lights are a little bit dimmer. So what this will translate to is under load conditions, so trying to start the car, there's not going to be enough voltage making it to the starter so that the starter doesn't engage or it doesn't spin fast enough and give you difficulty starting. So in that kind of scenario, what we want to do is we want to eliminate what the problem is not and try and focus on finding exactly what the problem is. So the first thing we want to do is we want to make sure that the problem is not a dead battery. So what we do is we always go and test the battery first. So we're still at 12.68 volts. So our battery is good. So what we're going to do now is we're going to do a test. I'm going to leave the positive, the red connector, on the positive side of the battery, and I'm going to go to my chassis. So I'm going to go somewhere on the chassis and take a measurement. You'll notice that I'm down to 9.33 volts. So at the battery, I'm getting 12.68. When I go to the chassis, I'm getting 9.33. So that indicates that there is a problem from the battery to the chassis. So that's where I have introduced that resistance. So that would be the first thing you would look at. So what you want to do is confirm that by going chassis to your fuse panel or some other line right off of your alternator. And again, I'm getting 9.29 volts. So it doesn't matter if I go here or if I go right to the battery, I'm getting the same reading. So that tells me that the red line that goes to my fuse panel is fine, and the problem is on the ground system into the chassis. So take the measurement from the battery, go right to your chassis. If it doesn't match the battery voltage, then you've got a problem in the grounding line to the chassis. All right, so what we're going to be doing now is we are going to be simulating a bad circuit ground. So the line from this light bulb, we're going to simulate a bad connection on that circuit to ground, and we're going to see how that shows up on the voltmeter. So let me introduce the resistance. There we go. Now you might see, and I'm not sure if the camera picks it up really well, but you might see that this light bulb is now a little bit dimmer than this one. So what we want to do now is we want to somehow detect whether or not we have a good ground here or bad ground here on this circuit. So let's say we are experiencing dim lights somewhere or something along those lines, and we want to be able to detect whether or not that circuit is fine. So again, first thing we do is we go directly to the battery and we get our reference. So 12.68 volts on the battery. So now we want to make sure that this is not a chassis ground problem. So we're going to go and take our lead and go directly to chassis. So from battery to chassis, and our voltage is good. So that is not a bad connection on the main chassis ground. So the next thing we want to do is we want to go chassis to our fuse panel and make sure we're getting the proper voltage, which we are. And then what we want to do is we want to go and we want to go directly to the light bulb and measure the voltage at the light bulb. Now the voltage at the light bulb should be 12.5 something volts. We are getting 10.6. So the voltage from the battery is not making it to the light bulb. So here is our test. What we want to do is we want to go from the hot side, so the red positive side of our light bulb, to the chassis. And look, we're getting our 12.3 volts. Okay, so we're getting the proper value from the light bulb hot to the chassis itself. But when I go back to the light bulb, I'm getting 10.4 volts. Okay, so that's telling me that there is a connection problem from this line, so the negative line off the light bulb, to the chassis. One way we can prove that is that if I go to this negative line off the light bulb and go directly to the chassis, I wish I had some way to hold these light bulbs steady, there we go, and go directly to the chassis, I should get pretty close to 0 volts. But I'm not. I'm getting 1.8 volts. So there is a voltage loss that is happening from this negative side of the light bulb to the chassis. So that is my indication that there's a bad connection on the circuit ground. So basically from the circuit, the light bulb, to the chassis on the return. Alright, so this next one is not as common as having a bad ground, but having a bad hot lead on a circuit. So what I'm going to do is I'm going to introduce my bad connection on the hot side of my light bulb circuit. So again, my light bulb is a little bit dimmer. So this would present as the same problem as a bad ground on the circuit. So again, the first thing we always do is we go directly to our battery and get our baseline voltage, so 12.68 volts. So now we're going to do our regular measurements. So we're going to go from the positive side of the battery to the chassis, 12.6 volts. So that means that the connection from the battery post to the chassis ground is good. I want to take this off of here and I want to go directly to my fuse panel, 12.6 volts approximately. So that means that the connections from my battery are good. So the first thing I'm going to do is I'm going to go to my light bulb and I'm going to take the voltage across my light bulb. 10.4 volts-ish. So what that's telling me is my voltage, the 12 volts that I'm supposed to have with the light bulb, is not getting there. So I have two possibilities. One is to loss to ground. Two is the loss on the hot line. So most common is the loss to ground. So let's go from the positive side of our light bulb to the negative side of the light bulb. Again, 10.5 something. Now I'm going to go from the positive side of the light bulb to the chassis ground. And I'm getting the same voltage. So that means that there's no loss in the connection from the light bulb to ground, because I'm getting the same in both. So that means that my loss must be before the light bulb. So what I'm going to do is I am going to go from my input at the fuse panel, and I'm going to go off to the hot on my light bulb. So the positive on my light bulb. Theoretically, I should get 0 volts because it's supposed to be just a wire. But yet, there's 2 volts, 1.9 something volts being lost from the connection into my fuse panel to the light bulb. So along that line somewhere, we're experiencing losses. So in this case, the loss is from the fuse panel, and we can go, let's say, to the output of the fuse panel, which would be here. Then we have our switch, and then we have our imitation loss to the light bulb. So in this case, even though the voltage that makes it to the light bulb is the same in this scenario as it was when we had a bad circuit ground, with this little test, we can figure out whether or not the losses are on the hot side or the losses are on the ground side. Alright, so the last test we're going to do is what happens when we have a battery that's going bad, and how does that look? So, if we had no lights on, so there was no load on the battery, we can actually go up to the battery and take our measurement, and we're going to see 12.69 volts. Now, if you have a cell that's going bad in the battery, where it really shows up is when the battery is under load. So, if you hook up the power supply, or the voltmeter, sorry, to the battery itself, and then you start turning on light bulbs, you'll see that the voltage actually crashes. With every light bulb we turn on, the voltage drops. If I start turning off the light bulbs, the voltage will start to recover. If you see a scenario like this and you're right across the battery, typically you have a bad battery.
Well, I hope this video helps you out somewhere down the line. Might have learned a few things. Shows you how important it is to have a voltmeter in your toolbox and how to use it properly. So, until next time, please take a minute, subscribe to the channel, like the video, and until we meet again, keep the rubber side down, everybody. Take care.